operation that doesn't work with numbers, that isn't an operation on numbers, but is reserved for just functions. So on the left we have an s of x function called x squared minus 2, and on the right we have a t of x function called radical x plus 4. So this operation called composition is like, think of it as machines working in parallel. So we have an input that goes into one machine, and then that input goes into the next machine. So s composed with t of 5 on the left here is going to be s of t of the number 5. So when I start to work on that, I'm going to have to do s of the value of t of 5. So if I look up at the t rule, that would be the square root of 5 plus 4. So now we can do a little bit of simplification in here. S of 5 plus 4 is 9, and the square root of 9 is 3. So 3 is not the original input, it's the input that, or the output of the t function, but it becomes the input into the s function. So s of the number 3 would be, looking at the s rule now, that would be 3 squared minus 2, and according to order of operations, 3 squared is 9 minus 2, and so the final answer is 7. Now interestingly, it turns out that composition of functions is non-commutative, and we'll see that on the right here, or on the right example. Here we have t of s of the number 5, which would be t of s of 5 would mean to stick 5 into the s machine, so that would be 5 squared minus 2, and so we end up getting t of, say, 25 minus 2 would be the number 23. So now 23, which was the output of the s function, becomes the input to the t function. So what is t of 23? Well, according to the t rule, that would be the square root of 23 plus 4, and 23 plus 4 is 27, and as we've seen in other cases, or in other examples, this reduces to 3 times square root of 3. So we got totally different numbers based on which order we did the composition in. So why don't you pause the video and try a couple on your own then. Here's a j and an h. J of x is x squared plus 9, and h of x is x plus 8. So assuming you gave it a shot here and tried it on your own, we have j of h of x. Now x is a generic variable, it's not a specific number, so that means all we can really do here, whoops, this is supposed to be blue, is j of h of x, which is radical x plus 8. Right? That's what h of x is. That's what the rule says over there on the right. So what would that be? Well, the j rule takes whatever it's given, which in this case is the radical of x plus 8, it squares it, and then it adds 9. Radical and square cancel out because they're inverse operations, so we end up getting x plus 8 plus 9. In other words, we get x plus 17. And that's the expression on the left-hand side. However, on the right-hand side, we would have h of j of x, which would be h of, now j of x means that that's going to be this x squared plus 9 quantity from over here, so that's x squared plus 9. Now h of that would be the square root of the object you were given, x squared plus 9, plus 8. And so the little bit of simplification that we can do is to get x squared plus 17 inside of a radical and put a box around that, because that's as far as we can go in that case.